Welcome back to another lecture from organic chemistry. In this lecture, I'm going to try to go through whether charged molecules can be aromatic, yes or no. Can we have an ion that is aromatic or cation that is aromatic? And let's tackle this subject. Okay, so we said in order to have an aromatic molecule, the molecule must be planar. So first thing, it has to be flat. Okay, and so our molecule needs to be flat, and also it says need to be and cyclic. So ring versus this one. Okay. This molecule is not, so it cannot be. And then it says it has to be flat. And here you go, flat. This one is a planar versus that one. The one on the right side is a chair. It has to be cyclic. And so this one, for example, this two versus, say, 1, 2, and let's put this one here. Okay, they have the same number of pi bonds. So we have technically 6 electrons or 3 pi bonds, but this one is cyclic. That's not. So that means that this cannot be aromatic. And next one, each atom must have one orbital that is like it is a p orbital that is either full or empty. Full or empty. It cannot be half occupied. Okay, so next, imagine this that you have this system. Okay, each carbon it has a pi bond. Okay, versus go such a system. Okay, here we have sp3 hybridization, and there as well sp hybridization. Well, each carbon in this case is sp2 hybridization. So I have all carbons are sp2 hybridization. Because they are sp2 hybridization, they will be flat or planar. And yes, both molecules are flat. Both molecules are cyclic. But the one on the right side, because it has 2 carbon atoms. Those 2 carbon atoms, let me highlight them. Okay, those 2 carbon atoms, they have sp3 hybridization, and each carbon is involved in sigma bonds with 2 hydrogen atoms. So we don't have empty p orbital there. Okay, all the p orbitals are used for sp3 hybridization. So that cannot be hybrid. And the last one, it says number of electrons supposed to be 4n plus 2, and to get the conjugated pi system. And so number of electrons have to follow this number. And so it's going to be, if n is equal to 0, it will be 2, and 1, it will be 6, and 2, it will be 10, and go on. So we need to follow these rules to have aromatic compound. Okay, now let's tackle the charged molecules. Can I have aromatic compound? The first one, it has 3 pi bonds and 2 lone pairs. So we have 1, 2, 3 pi bonds plus 2 lone pairs. That means we have 5 pairs. Okay, 5 pairs means 10 electrons. So this one is following 4n plus 2. And this is going to be 4 plus 2 plus 2. We get 10. So is it aromatic? Yes. Why? Because it's following the Huckel rules. Is cyclic. It has a p orbital on each atom, and we have 10 electrons. So that's going to be correct. Next one also, as you see, is following is ring, and it has its p orbital either full. Okay. For the second molecule, all p orbitals are coming with electrons. So I'm going to say I have 1 pi bond plus 2 lone pairs. Okay, that's going to be 6. So my molecule, again, it will be aromatic. And here we have 2 pi plus 1 lone pair. So 2 pi plus 1 lone pair, it will be 6. Next one, we have a 3 pi plus this one is empty. Okay, so there is no electron in it. This time it's empty. And if you remember, like when we talked about the aromaticity rules, we said the orbital is going to be either fully occupied or empty. Fully occupied or empty p orbital. And so the molecule, this cation, is cyclic, and all carbons have sp2 hybridization, including the carbon with a positive charge. And because all of them are sp2 hybridization, it will be flat. Okay, and because it's a flat and it has 6 electrons, so this molecule will be aromatic. And how about the next one? The next one, it has only 1 pi bond. That means 2 electrons, and also in the carbon with a positive charge. So this one, it will be 2 electrons plus empty orbital, and we're going to get 0 there. So we have only 2, and that means it's n equal to 0. So 4n plus 2, 4 multiplies 0 plus 2, that's going to be 2. And so the molecule, it will be aromatic. And next one, Next one, we have two carbons that they have empty orbitals. The rest, they have pi, orbitals that we do have electrons inside them. And so I have 3 pi bonds, means 6 electrons, 0 lone pair, and I have 2 empty orbitals. So this system, it will be aromatic, and even we have 2 empty orbitals. Okay, and that's fine because the hybridization here again, it will be sp2 for those two carbon atoms that they have positive charges. How about this carbon? That carbon again, it will be sp2. So that means your molecule will be flat or planar. So all of them will be aromatic. Now let's tackle this question. Which one of this molecule is aromatic? Pause the video here and try to go through this question. And I might actually design some question about them whenever you are watching the video. Okay, very good. So the first one, I'm gonna say I have 1, 2, and 3 pi bonds. 3 pi bonds. So 3 pi bonds means 6 electrons. So this one is following the Huckel rules. Now what will happen with the lone pair? Okay. Lone pair, because we already have 6 electrons, lone pair it will be pointing out. Okay, so do not include the lone pair. And the nitrogen atom already is already involved in a pi bond. And there is a double bond there. And that double bond, you got it through one, pi bond between nitrogen and a carbon atom. So you cannot add more than 2 electrons from one atom in order to get aromaticity. So this one is aromatic. Now, how about next one? Next one, nitrogen is already involved in a pi bond. What does it mean? Nitrogen already shared electron for a pi bond. Okay, it means this nitrogen, it has a lone pair, and that lone pair, it will be pointing out. Okay, so we have 1, 2 pi bonds. So 2 pi means 4 electrons. We are missing 2 electrons to be aromatic. So oxygen is going to share 2 electrons, and the 2 more, it will put them lone pair, and that lone pair also will be pointing out. So plus 1 lone pair from oxygen. Okay, from oxygen, not nitrogen. Okay, not nitrogen. So this one, it will be 6 electrons, and it will be aromatic. Okay, how about next one? Okay, next molecule. Okay, before I go through the next molecule, and you might say, why don't you just simply add electrons of nitrogen, the lone pair? I said nitrogen is already involved in a pi bond. You cannot add more than 2 electrons. Nitrogen already added, shared 1 electron through a pi bond, and so you can't have 3. Plus, if you don't share lone pair from oxygen, hybridization here, it will be sp3, and that molecule is not going to be flat anymore, and that's going to be a problem, because if it's not a planar, the molecule will not be aromatic, and so the molecule will change the hybridization to sp2 for this oxygen in order to make it flat, and so then we can benefit from aromaticity. Okay, next molecule, look at those 2 carbons. Those 2 carbons, they have sp3 hybridization, and because they have sp3 hybridization, they will not be flat. And yes, we have 2 electrons, means n equal to 0. So n is fine, okay? N is fine here. We are following the 4n plus 2, but we have 2 atoms that they don't have empty or fully occupied p orbital. And here we have sp3 hybrid orbital, not atomic orbital, okay? P is atomic orbital. Well, sp3, each sp3, we call it hybrid orbital. You're supposed to have atomic p orbital on each atom in order to have it, in order to have aromaticity. So C cannot be. Okay. How about D? Okay. And I'm gonna leave this one for you guys. Look to those 2 atoms, and what's the what's the hybridization of those 2 atoms? And can I share lone pair from oxygen? Okay. Remember, you have 1, 2 pi's. So 2 pi's means 4 electrons. How far we are from 6? 2. And so can we use 1 lone pair? Okay, if we use lone pair from oxygen, it will be 6. But then how about this atom? Okay, so think about this one. Yes or no? Which one? Okay. Next compound. Next compound, we have 1 2 pi. So 2 pi means 4 electrons. And can we make it to 6? And yes, it's possible. Let's use those 2 electron lone pair of nitrogen and share it with the ring. If we share 1 lone pair from nitrogen, we will have 3 pairs. Is 6 electron, and the molecule is cyclic, and because each element also it will have sp2 hybridization. So the molecule is cyclic, planar, and we have 6 electrons. So this system, it has a conjugated pi system. It will be aromatic, and the answer is going to be yes. How about next molecule? Next molecule, we have 3 pi means 6 electrons. Okay, so we are following for n plus 2. That's fine. Now, is it planar? Okay. Like the molecule, it has sp2 hybridization on each carbon atom. So it's planar, but the problem is it's not cyclic, okay? Because it's not cyclic. So I'm going to say non-cyclic or acyclic. And so this molecule will not be aromatic because there, in order to be aromatic, it's supposed to be cyclic. But this one is acyclic or non-cyclic. Next one, we have only 1 pi bond. That means 2 electrons, and we have 2 empty orbitals. And molecule, it has 2 electrons, so n is going to be equal to 0. For n plus 2, it will be equal to 2. So we are following for n plus 2. Now, is it cyclic? Yes. Do we have a p orbital and a p orbital on each atom? Yes. We have either full or like or we have empty orbitals. So this molecule, it will be planar, cyclic, and it has 2 electrons. So I'm going to say this one, it will be aromatic. Okay. And I'm going to stop the lecture here, and thank you very much.